Hey folks, welcome to class Kinematics 101. It's our first lesson on a series of lessons that we'll be running over the course of the term. These lessons are here for you to jump back on in case you miss some content or in case you need a bit of revision or something like that when it comes to the end of the term or semester. So what we're going to be looking at is really the understanding of kinematics, which is a really cool word. It sounds very similar to kinetic energy, which is the energy of movement, and that's to do with this first part. I don't know the Latin behind it, but kinematics. There's a lot of things you could say about it, but it's really the study of motion. Now, motion, movement. Where is something going? How fast is it going? What was causing that motion? Are there any forces involved? Will that motion cause other motions down the track? There's a lot that you can unpack there. In year 11 physics, you will do a lot of that. You'll do a lot of sort of equations and things like that if you're interested. But for us, we're going to keep it to the basics. And what we're doing with this first lesson is we really just want to understand the definitions of a key few terms and using those definitions to classify some things. And this is an important step in any subject, but really important in science, where we need to be able to communicate with the same language, and we need to have a common understanding of some of the words that we use, because when down the track we want to, observe something and explain what's going on, it's useful to have that common language. So the first two words, one of them you'll probably get pretty quick. First one is direction. Now, direction is one of those words where you're like, everyone kind of knows what direction is. Direction is, direction. Another way to explain it is where an object is going. You could even take it a bit further in 3D space. If it was on a 2D object, it's like, where is it going from left to right or something like that. But I guess I'm just going to keep 3D space for that moment because that's kind of what we're going to be looking at. And the next one is magnitude, which you might not have heard of. Magnitude really just means how much of something. How much of something. And if you want to write these into your books as I'm going, it's always better to write this in a book rather than on a computer or something like that. There's a bit of research behind that, but it helps you sort of memorize these terms a little bit better. How much of something there is, and it's usually it's a number, okay? So you could say something's going fast, right? And that would be magnitude. Fast doesn't really mean much to us when we get technical or like very accurate. So something might be, 10 meters per second. That's a magnitude, okay? Or even 25 kilograms, like that. Now, direction just means a couple of examples that we could say. We could say left. We could say up. We could say north. Sideways. Maybe not quite this one, but if you're spinning, there is a direction to that. If you can think of your face, but it's a changing direction there. So the next two words that we're going to use are going to use information that we've just learnt about direction and magnitude. First of all, we've got scalar. And scalar, we could call it a scalar quantity. Quantity is just meaning how much. And these are really just things that involve magnitude only. And some of the examples I used beforehand, 10 kilograms, we could say 3 meters per second, or even 3 meters. Some other ones that might crop up is you could say 10 degrees Celsius or 6 people. These are all, in a sense, scalar quantities. Now, scalar, when it comes to kinematics, doesn't really do that much for us because it's just saying like how much of there is something. But we don't when we're talking about motion, we need to have an understanding of three-dimensional space. And so that's when something called a vector quantity comes in. And vectors is really what it's really a vector quantity. Vector quantity is what we're going to be using a lot more in understanding sort of the direction of something. And that it has not only a magnitude, but it also has direction. So I could say 3 meters per second up. So I'm just going 3 meters per second up. And it has a magnitude and it has a direction there. Another one could be 6 newtons, which is a force, which is an expression of force. We'll look into this later, but it just means there's 6 kilograms being pulled down to the earth. So there's, in this case, so it's incorporating a direction in there. Our last 2 words that we're going to look at is origin and relative. So origin is the starting point. Starting point of a moving object. Now, origin can mean a whole bunch of other things, like where did you originate from? What's your origin? I'm from Africa or Holland. I'm from my mum. But in this case, origin for us means the starting point of a moving object in this class. The other one, as I said before, was relative. And that means comparing a point in space to another. It's not just space. Sometimes we could say space/time, because I could say, where am I relative to you in time? Technically, I'm in the past because I filmed this. In space, I could be 5 meters to the right of you relative to where your position is. So hopefully this makes a little bit of sense. So by way of example, might be this dude here, and he decides to go for a walk. Okay, and oh, it's not that good. It's hard to draw straight lines on this thing. But he walks and he covers 10 meters. It doesn't really matter about the time in this case, but he ends up at this place, and I'll just draw a little silhouette over here. And there's one question I could ask you, which is, where is he relative to his origin? Where is he relative to his origin? At the end of his trip. That's a convoluted way of saying, where did he end up? And in this case, we could just say, well, 10 meters to the right. In this case, we're talking about 2-dimensional space. It's not 3-dimensional or anything like that. That gets a little bit more complicated. So hopefully that kind of makes sense. That's 6 words that were broken down. They're very basic in their own right, but they do make life a lot easier for us in the future. So there'll be some exercises after this video for you to look at, which is just going to put those things into practice. In particular, classifying things as either scalar or vector quantities. Peace out.